In the first video on the binomial theorem, we got as far as expanding the simple binomial x plus y all to the n and finding the general term for that expansion. And there it is on the bottom of the left-hand page on your screen. Now I want to take that a step further and get a more general expansion. Instead of x plus y to the n, let's expand the binomial ax plus by all to the n. And if we do that, the general term just gets the a and the b added in along with the x and the y. There's nothing too complicated here. But there is one really important point that I can't stress enough. The a and the b must go inside the brackets so that they are also raised to the power. If you don't put those brackets in, you're going to come to grief. So that's really important. The other warning here before we go any further is that the binomial must be written in the form we've got it there, ax plus by all to the n. So if we're given, for example, the one here, 3x minus 2y all to the 8, the very first thing to do is to rewrite that in the acceptable form. So we have to write it as 3x plus, in brackets, negative 2y, bracket, all to the 8. And then we can see that by is in fact negative 2y. If we don't handle that, we lose a negative and we'll often get the wrong answer there too. So now let's use this. So we've been asked to find the coefficient of x to the 6 in the expansion of this 3x minus 2y all to the 8. In other words, we have to find r. That's the unknown. The r is the term. Which term is it that has x to the 6 in it? And then find the coefficient of that term. How do we do that? The first step, as I just mentioned before, is to rewrite the binomial in the correct form if it's got a negative there. So 3x plus negative 2y all to the 8. Then we write down the general term. And I strongly recommend just putting it down exactly in this general form with the a's and b's. Just write it in its most general form to start with. Then substitute in everything we know. We know that n is 8. Put that in. So it's going to be 8cr. R, remember, is what we don't know. We're going to solve for that. So it's going to be 8cr. Then it's the a. Ax is 3x, so we put that in the bracket. 3x all to the power of n minus r now is 8 minus r, times, in brackets, by, that's negative 2y, all to the r. And we're actually a few steps away now from solving it, but you might wonder how. The trick here is to collect up your terms. First of all, on the left-hand side of the expression, you collect all the constant terms. Everything that doesn't have an x or a y in it, bring that out together on the left, and you'll see why very soon. So let me do that now. I start with 8cr, that's a constant, there's no x in that. I bring the 3 out of that bracket, so that there'll be a 3 to the power of 8 minus r. I bring the negative 2 out of that y bracket, so there'll be a negative 2 to the r. And then I'm just left with the x and the y terms. X to the 8 minus r, and y to the r. Now, that's the hard work done, because we've been asked to find the coefficient of x to the 6. Well, what have we found the power to be? X to the 8 minus r. In other words, if we're looking for the term in x to the 6, 8 minus r has to equal 6. Pretty simple, r's 2. Now, if r is 2, we can straight away find the coefficient of x to the 6. So we go ahead, put r equals 2 in here, and we've got our coefficient. 8c2, 3 to the 8 minus 2, negative 2, all to the 2. Work that out on your calculator, 81648, that's your answer. That doesn't take many lines when you just go carefully through the steps, collect your terms correctly. It all works out quite quickly, and certainly a lot quicker than multiplying that thing out. let's look now at another example with one more trap to beware of. So find the coefficient of b to the 6 in the expansion. What have we got? 2b squared minus 1 over b all to the 12. Now, first thing you might notice is this is this still a binomial? There's only one variable. Certainly we can treat it as a binomial. There's no problem with that. So we've got two problems with it though. Firstly, we've got that negative there again, but we know how to handle that. The second thing is we mustn't write the 1 over b. We've got to bring all the variables up to the numerator. So 1 over b we have to write as b to the negative 1. They're the two main traps, and they're both in this problem, and so now we'll go ahead, being careful of those, sort them out straight away before we go any further, and the rest just flows as it did with the last problem. So here we go, we rewrite our binomial. This time it's only in the one variable b, so I've written the binomial in b is 2b squared. The negative we know we write as plus, negative 1 over b is b to the negative 1, put that back in its brackets, all to the 12. There, if you do that, get that done absolutely strictly, force yourself to do that before you go any further. You won't have any problems with these. It's if you don't do that properly that you come unstuck. So now we just write our general term down again. We substitute in what we know. Here's n is 12. 2b squared, no problem, we just put that in the bracket, all to the n minus r, 12 minus r. The negative b to the negative 1, all to the r. Collect up the terms. So out come all the constants. 12cr, 2 to the 12 minus r, negative 1 here, negative 1 to the r, leaving me then with a b squared to the 12 minus r, b squared to the 12 minus r, and a b to the negative 1 to the r. I have to keep going with a bit of algebra to tidy this up. 12cr, 2 to the 12 minus r, that stays, minus 1 to the r. Okay, now it's the b terms. B to the, it's 24 minus 2r from that one, and then minus r from that one. Collect them all up as the powers of b. So the coefficient all stays the same. Then it's just simply b to the 24 minus 3r. And then we were asked for the term in b to the 6. So the power of b has to be 6. In other words, 24 minus 3r equals 6. Straightforward again, r is 6. Then straight back into the coefficients part of this equation. 12c6, 2 to the 12 minus 6, negative 1 to the 6. That's it. That's the constant part, the coefficient. Work that out. 59136. Beautiful. So, the process you go through with all these questions is basically the same. So, first of all, as I've stressed, write the binomial in the correct form, making sure the two terms are separated with a plus, not with a minus. First thing to check. Second thing to check, still in the step 1 there, that the variables are all on the numerator. If any are on the denominator, you've got to bring them up to the numerator and write them to the negative power. Once you've got your binomial in the correct form, step 2, write down the general term, substitute in for your n and your a's and b's, whatever else you know. Collect all the constants at the front, step 3. Collect up your powers, step 4. Equate the power of the variable in question to the value that you've been asked for in the question, and that will give you the value of r. That's what you're trying to solve for. Once you've got r, substitute that back into the constant part of your general term to find the coefficient of this particular term for that value of r. That's it. That's all there is to it. Just one final point of terminology. If the question asks for the term independent of x, that simply means they're asking you for the power of x is 0. That's no problem either.